This video is to finish this example on the analysis of variance, the ANOVA test for the miles per gallon of different types of cars. So we have the null hypothesis, we have the alternative hypothesis. The F-test statistic and the p-value was figured out by a calculator. So did the degree of freedom factor and the degree of freedom error. What these are is it takes a look, so this factor degree of freedom takes a look at the smallest L, the smallest list, and it subtracts 1. So because the smallest list only had 3 items in there, this will tell you the degree of freedom of the most conservative list, the smallest list. The degree of freedom error basically adds up all of the data that we have. So we had 5 from the sample number 2, and then 7 more from the others. So that's 12. And what it did is subtracted the smallest group. So this is how they got the degree of freedom factor and the degree of freedom error. Now what we're interested in is we want to go back into that alpha, which is given to us at 0.05 in the test. So this was just a bit over 7%, so just under 4% actually. Regardless, it is smaller than 5% presented alpha. So what we do is we reject the null hypothesis. If you reject the null hypothesis in favor of the alternative hypothesis, it does mean that at least one mean is different. So this is how you would write this down. At least one mean is different. We did find evidence that the size of the car has something to do with miles per gallon. Now, just like your chi-square test, if you reject the null hypothesis, you actually need further research. Meaning, what is the relationship between the 3 cars? Which one is different? In order to find which one is different, you actually run a 2-sample means 3 times. For 1 and 2, 2 and 3, and then 1 and 3. So you can do that. Of course, if you have more than 3 samples, that gets cumbersome. So if you have many samples, for example, you are trying to figure out if all of the coffee machines in the office building dispense the same amount of coffee. So you know it's supposed to be 8 ounces. You test machine 1, machine 2, machine 3, maybe there's many machines, and you find the averages, or you record these cups of coffee per machine, and then let's say you have 28 machines that you need to test. Well, they're all supposed to have 8 ounces of coffee. So if you run this test and you do not reject the null hypothesis, meaning all of the means are the same and they're all look like they're all 8, what you've done is you have finished your research in one step. But if you reject the null hypothesis, what it means is you actually have to go back to the office building and figure out which is the machine that kind of managed to reject the null hypothesis. What was the aiding machine that rejected the null hypothesis? Or maybe there's more than one. So there's further research necessary. As far as our class, this is the only example that I have in 12-1, and this is the end of this course.